All right, so 5.3. So this is a tough section. Once you get the hang of it, it's not bad, but it's tough at the beginning to figure out what's going on. So pay close attention. Let me know if you have questions. Um, but basically, what this is systems of equations with three variables, so like x, y, and z. Okay. What this looks like graphically, you're never going to have to graph these in this class, but what it looks like graphically, basically, if you have x, y, and z in an equation, instead of being a line, when you have x and y, you add z and it makes it three-dimensional. So it's basically a plane, right? So what we're looking at is where three planes intersect, or sometimes maybe two planes intersect. And that's what this whole section is about, okay? So, yeah, basically just said that stuff. Just something to note, when two planes intersect, that gives you a line. So it's like if you took think about two pieces of paper or you have two walls that intersect, they intersect in a line. If you have three planes intersecting, so think that's like the corner of a room. So maybe like the top corner, if you look wherever you're sitting right now, look in the top corner of your room, you've got three planes intersecting. You've got two walls and you've got your ceiling. Okay? Unless you live in like a circle house or something cool like that. Anyway, so that's kind of what's going on here. So first thing, one thing that you'll have to do is set up systems of equations with three variables. It's just like with two, do it the same way. So figure out our variables. And again, what are we trying to find out? So if you take a look at this, you might pause it and watch and read through this. We're trying to figure out here how many we've got. I have a nursery side business where I sell bushes, trees, and perennials. Got cost for bush, cost for trees, cost for perennials, and then I also charge to plant them. Also charge insurance for if they go bad or whatever. And then screen just went black. There we go. Lady named D Nice comes and she's budgeted $1,000 for purchases, $400 for planting, and $150 for insurance. We've got all this information. What we're asked to find is how many bushes, trees, and flowers should she purchase to use the exact amount of money she has. Okay? So as you do these, again, what are we trying to find out? This is what we're trying to find out. So that's my X, my Y, and my Z. All right? And then just write equations for each piece of information I have. So I have just buying them. So that's going to be my first equation. So for cost, okay, if bushes are X, trees are Y, flowers are Z, you've got 20 per bush, 40 per tree, and then the perennials, the flowers are $2, so 2Z, and then she has 1,000 budgeted to make those purchases. So I should maybe instead of saying cost, I should say for purchases. Okay, so that's one equation. Then you have money for planting also, so write equation for that. So for planting, it was $10 per bush, so 10x, 10 per tree, $1 per flower, and she has 400 available for planting. Then same deal for the insuring. Okay, we have, find it on there, $4 per bush, $6 per tree, and 20 cents per flower, and she has 150 to spend. So those are my inequalities. So the goal of this section is to be able to solve things like that, to figure out how many of each she needs. All right. Most of the ones we do won't have numbers this big and this complicated. It's kind of a pain to do. So, but that's the setup for them. In the real world, you would not do this by hand. You use computer or calculator. All right. So let's just say I have an equation like this, or a system of equations like this. We're talking about how would we go about solving it. Okay. You might think maybe use elimination. Maybe multiply one equation by something and then add and subtract them to get rid of a variable. All right. That's, really what we're going to be doing here. Okay. So we're going to kind of set these up, but we're going to do it a little differently than you normally use elimination for. Okay. So we're going to introduce is what's called a coefficient matrix. Okay, where basically we get rid of the x, y's, and z's, and we just write it in a matrix, which is just a array of numbers. Okay, it's a way to organize numbers. All right, where this first column is those are my x coefficients, then the y coefficients, and the z coefficients. Okay, so at that first equation, let's go back to it. This first one. So the coefficients were 2, -1, and 2. Notice that's the first row. Okay, and then the second row, these coefficients. So the 1, 2, and -3. That's where they are there. And then same thing with the last equation, the 3, -1, and -4. There they are. So that's called a coefficient matrix. We just take the coefficients and put them in a little table. Okay, and then what we do is we make what's called an augmented matrix, which is really just the equation, or all three equations, written out, but just with the numbers, right? And the part over here, notice what that is. That's the part that's on the other side of your equal sign. Okay, so all it is just taking all of our numbers and putting them into a table. And we just put a little line between where our coefficients were and where the equal sign was. So this is the x, the y, the z, and then what they all equal. Okay, that's called an augmented matrix. Okay, so what we're going to try to do is we're going to try to get this in what's called a reduced form. All right, we're going to try to just do some things like multiplying, adding, subtracting columns, rows, to try to eliminate things. Okay, so reduced form, kind of three things here. Entering the first row, first column is 1. So we want this to be a 1. And then all the others in that row are 0. So in other words, we want to have a 1, 0, and a 0 in my first row. Okay, in the second row, we want that to be a 0, and we want this to be a 1, and then a 0. Okay? And then in my third row, our 1 is there, and these are zeros. Okay? What this tells us when we do this, so we're going to do some stuff to it. I'm going to show you how in a minute. Okay, you might end up with something like that. All this means, so if you remember back, I have my x's, my y's, my z's. All this tells us, having the 1 there and the 5 there, that tells me since the 1 is with the x, that x is 5. This one is with the y's, that means y is 7. This is with the z's, that means z is 2. That's what we're going to get to. Those aren't the answers to this problem, but that's what we're trying to get. Okay? And this is going to seem kind of time consuming and whatnot, and it is. All right, solving systems of equations with 3 variables is time consuming. Doing it the way I'm going to show you does, though, it's just easier to organize. You don't have to keep writing all the x's and the y's and the z's, and it's just like I said, the organization is a little easier. Okay, so on that problem we had, this is what the final answer is. Okay, we end up with this. If we work this out, that's what we end up with, which tells us these things. Okay, meaning we have our answers. So now we're going to look at getting to this. Okay, so I'm going to have to write this on a smart board. Hopefully I can get as much fit on. I might have to kind of erase and do some stuff as we go. It's going to be a lot of steps. So make sure, take notes here, follow along, pause as you need to. Make sure you leave need a lot of space for these. Okay, so let me just go back to. No space here. Left that slide apparently. Okay, so we'll just start with this. Okay, so we're trying again to get 1s to be there, everything else to be 0s. All right. One thing that we can do, let me run back to some of the rules here. Okay, we can interchange our 2 equations, or our rows. So in other words, if I feel like it's going to be easier to switch these 2 rows, you can do that. All right. What that means is when I get to the end, if I don't have the 1s in the right spots, like say this was 0, 1, 0, and this was like the 0 was there and the 1 was there, I can just switch the rows and I've got it. Okay, so rows can be interchanged. Okay, we can multiply any equation by any non-zero number, all right? And then we can replace any equation with the sum of that equation and the multiple of another, okay? So actually, here's my blank slide. So let's go ahead and figure this out. So one thing as you're doing this, don't worry about the ones until the end. Don't worry about getting these ones until the very, very end. Worry about getting zeros, okay? So what I like to do is I try to pick a column and I try to get zeros in that column first, okay? So if we take a look, I've got those two numbers there, those are the same, right? So if I subtract my equations, I can get a zero. So what I'm gonna do is I'm gonna take row 1 minus row 3. I'm gonna write the new matrix down below here, okay? So I'm taking, and I'm gonna make this a new row 1, all right? So row 1 minus row 3, so that's 2 minus 3, that's gonna give me -1. -1 minus -1 will be 0. Then I need to take 2 minus -4, so that's +6. And I'm going to take -8 minus 3, so -11. Okay? Be really careful as you're going through these, working with your negatives. Okay, that's where mistakes. That's where the mistakes are going to happen. All right, it's just simple arithmetic errors. All right, so now you can write what's left. As you get good at these, you can kind of like combine steps, but I want to show each one individually here first. So next thing I want to do, I want to try to get the zeros in the column. So I want to try to get this -1 to a 0. So I can do that by working with row 2. So if I multiply row 3 by 2, so if I take 2 row 3 and add that to row 2, because if I take 2 times -1, that's -2. -2 plus 2 is 0. That's going to be my 0 down here. All right, so let's do that. So I have to change row 1. I'm not changing row 2. I'm going to make a new row 3 here. So rewrite row 2. Okay, so now row 3, I'm taking 2 times row 3 and then adding row 2 to it. So 2 times 3 is 6 plus 1 would be 7. I've already said 2 times -1 plus 2 gives me 0. 2 times -4 would be -8 plus -3. So 2 times, so I mean negative, I'm trying to do this right, -8 plus -3 is -11. And then 2 times 3 is 6 plus, so 9, so 15. Okay. All right, so I'm taking care of this middle column. All right, we'll worry about that 2 in a minute. All right, so now we need to pick another column and try to get zeros. So at first glance, I would probably try to get a 0 right there. Okay, because I can just take that and I can add it to row 1 and I'll have a 0 there. So I'm just going to take row 2 plus row 1 and I'm going to write a new row 2. Okay. So I'm not changing row 1. That stays where it's at. Okay, I add row 2 to row 1, so that's a 0, stays as a 2. -3 plus 6 would be +3. 9 plus -11 would be -2. And I have not changed my last row. Okay, I'm getting there. So now I need to get this 7 to be a 0. All right, so the only thing I can work with is this top row. So I can take row 3 plus 7, row 1, and I'll have my 0 down. Okay? So again, nothing has changed in row 1 yet. So that's staying where it's at. Haven't messed with row 2 here. So row 3 plus 7 row 1 gives me 0 there. So 0 there. And then I've got negative 11 plus, so this plus 7 times 6, so negative 11 plus 42, so 31. And then I've got 15 plus negative 77, do these two, so that's going to be negative 62. Okay. Now, we're almost there. We've got some big numbers down at the bottom there, but if we look at that, 31 goes into 62. So what I'm going to do is I'm going to do row 3 times 1 over 31. Or in other words, I'm dividing row 3 by 31. Okay? So, focus is going to, you're going to need a lot of space. So, row 1 stays the same. Okay, one thing as you're doing these, be careful with copying everything down from the previous step. Because I've seen people a lot of times when they make a mistake just because they left a negative off when they were copying down the table. So, my new row 3, dividing everything by 31, gives me my 1 there, my negative 2 there. Negative 62 divided by 31 would be negative 2. Okay, so now I'm real close now. I need to get this last column, I need zeros there and there. Okay, so here's where it can be a little tricky. We want to make sure we don't lose a 0. All right, so if I try to take like row 1 and use, so let's just say, don't write this down, but let's say I did row 1 minus 2 row 2. Okay, that's going to get rid of this 0, which we don't want. So we don't want to work those two together. Okay, so what we want to do instead is work with, so take row 1 with row 3. So I can go row 1 minus 6, row 3 to get rid of this. Okay, so we do that. Doesn't change that. Okay, still 0, which is what we want. 6 plus negative 6 is 0. And I've got negative 11 plus positive 12, so that's just a 1. Do that right. Negative 11 so plus 12 should be right. Okay. And then next row, that'll change. Okay. Now I just need to get this to a 0, and we're pretty much done once we do that. So I'm going to take row 2 minus 3, row 3. Okay. So that stays as 2. That goes to my 0. 3 plus negative 3 is 0. Then I've got negative 2. Sometimes it helps to write these down. So negative 2 minus 3 times row 3, so 3 times negative 2, so that's going to be negative 2 plus 6, so positive 4. Okay, now all I've got to do, basically I'm done. I don't really even have to go any farther. I can just write this out now. Remember, that's x, y, and z. So negative 1x equals 1. I have 2y equals 4. I have 1z equals negative 2. So in other words, x is negative 1, y is 2, z is negative 2. And hopefully I did that right. Okay? I forget this. Yes, I did. Thank goodness, because I did not want to redo this whole thing. All right? So as you can see, it's a lot of work. It really just takes practice to get better at this. I can do more examples as needed. I don't want to make this video like 45 minutes long, but I can add more examples of the homework problems and whatnot as we go. All right, so some inconsistent systems, what those are called. Basically, that is a system of equations that has no solution. Okay, in other words, they don't cross. Right, they're parallel. So to know if we have that, basically when I work these out, okay, if I have a row with 0 on the left side, so like this, and then a number here, okay, as long as it's 0 and a number, that means it's no solution or it's inconsistent. Okay. Again, it has to be all zeros on a row and then a number. Okay, because basically what that tells us is 0 equals 5, which is not true. Okay. Okay, if we get something like this, okay, so we work it all out and we get a whole row of zeros. Okay, what that tells us is we don't have a single solution. Okay, we have infinite solutions, and we have what we say is one or more of the variables we say are arbitrary. And that's I'm going to show you here in a second. Okay, and basically, I guess you can read that. I'll talk about it. But we state the variables in terms of the other variables in the end. Okay, I'll show that here. Okay, so here's our situation. We've got this system. So let me just write this out in matrix form. Okay, so in this case, I only have 2 equations. Okay, but I have 3 variables. So most of the time when that happens, we're going to have what's one of these. Okay, where I have a row of zeros or we don't have enough equations for variables. Okay, but let's go ahead and write it out. So we have 3, 2, 4, and 12. And notice my second equation, I'm missing the y. So what that means is y, but the y, the middle one, is 0. Pay close attention to those as you go. Because right now I know I'm going to have some issues. But we need to try to get this reduced as much as possible. Okay? So we've got a 0 in my middle row, or middle column. We want to leave that middle column alone. We're going to try to get another 0 somewhere. So if I work with if I change my bottom row, I'm going to lose this 0. So we don't want to, if we try to do anything to it, we're going to lose that 0. So let's not do that. Let's try to get a 0 somewhere in my top row. So let's just try to get a 0 right here. Okay? So I can take 5 times my first row minus 4 times my second row. And that's going to give me a 0 right there. It's kind of like getting a common denominator. All right? Multiplied by the other coefficient and vice versa, and then subtract in this case. So we do this. So first one, so 5 times that, so 15 minus 8, so that will be a 7. And then I'm going to have 10 minus 0, so 10. 20 minus 20 is 0. And then I'm going to have 60 minus 40, so 20. And then bottom row we didn't change. Now if we look at this, if I try to get any other zeros, if I try to get a 0 in either of those spots, you're going to lose your other 0. Okay? Meaning we're basically done here. All right? And then we need to write out how we write out our solution. Okay? So what we're going to say, since think about this is x, y, and z. So right now, the way I have it set up, I have x is showing up in both columns, okay? So we're going to say that x is arbitrary. And then we write the other, basically they're both equations in terms of our other variable. So remember, these are just equations. So that equation, 7x plus 10y, z is gone, so equals 20. Then I have the bottom row with my other equation over here, 2x plus 5z equals 10. So what we do is we write these in terms of, since they both have x, okay, we write this, like, in other words, we solve for the other variable. So I'm going to solve my first equation for y, meaning I'm going to subtract 7x, the other side, and then divide by 10. Okay, so I say y is 2 minus, let's say, 0.7x. Another equation, we subtract 2x over, divide by 5. So that's 2 minus 0.4, you can read the rest fraction. Okay, so this is how we write our solution. We say y is 2 minus 0.7x, z is 2 minus 0.4x, x is arbitrary. Okay? Now, basically, long story short, what you'll see on like a test is we have infinite solutions how many arbitrary variables do we have? We have one, okay? Because x can be anything because it shows up in both equations. So we say we have infinite solutions with one arbitrary variable, okay? In this case, x was arbitrary, but that just depends on the route I go to simplify this, okay? If I went back to the start and I got one of those as zeros, I would have a different arbitrary, have z be arbitrary, okay? What you need to know, though, is you end up with one arbitrary variable, okay? Now, like I said, whatever shows up in both, okay, that's what we solve, or we solve for the other one, so, okay, the other variable. Okay, so if you want to pause this, you can write this down and take a look at it. It's kind of a algorithm for doing this. I don't necessarily follow this. I think it can make it a little more complicated. Like I said, really, if you just go back to the other slide, and you try to get zeros in your columns and just work that way, I think that's the easiest method. That's what I've had the most success with teaching it and doing it myself. So I've got one other thing just to finish with. Get it up here. Okay. Okay, if we have, so notice what this says, so n variables, and we reduce it down, and we have basically fewer rows than variables. All right, so like this last one, I had fewer rows, so when I simplified it down, I had 2 rows, but I still had 3 variables, okay? So fewer rows than variables, that's where we say we have infinite solutions, and basically the difference between the rows and the variables, that's how many arbitrary you have, okay? So if I work something out and I had, let's just say I finished with this, something like that, okay? Where now I've got 4 variables, 2 rows, okay? That means n minus k, so the number of variables minus number of rows, that's the number of arbitrary. So 4 minus 2 means 2 arbitrary, okay? And that's what you need to know for a test. Like it will ask you, what is the solution or whatever. One of the choices would be it's infinite, and it'll say like 1 arbitrary or 2 arbitrary. All right, so you reduce it all the way down as far as you can go, where you can't get any more zeros, and then you find the difference between the number of variables and the number of rows. Okay, so anyway, that's it. A lot going on in this section. Send me questions, ask me questions, and we'll make it through it.